Hello, this is Mike and Veli, and welcome to another episode of Modernization Accepted. Today, I'm with Veli, and I'd like to talk a little bit about what it means to build for resilience. Well, first of all, Veli, what is resilience in context of software?
Yeah, hello, Mike. Well, resilience is the system's ability to endure failure, right? Or the success of continued operation when something bad happens and you don't expect it.
Yeah, that's a good way of putting it. I like how we're talking about keeping systems running. Um, Does systems start and stop with the software? Does it include the network? Does it include your IT staff? How big are we talking about when we're talking about systems that need to be resilient?
Yeah. So talking about system resilience, we should also talk about organizational resilience, right? Because teams that build software need to be resilient by design so that they produce resilient software. So we can safely say that it spans beyond the technology and into the organizational structure that is building that technology.
Sounds good. Now, I had Veli send me a list of 10 items that he thought were pretty good best practices. Now, I'm pretty sure that some of these are going to be pretty well known to most of our audience. So, Veli, if I could just kind of run through these real quick, and where it's not as simple as I think, I'm hoping you can expand a little bit. Does that sound good?
Sounds good to me.
Great. So the first thing on the list is deployment planning. Um, actually, okay, this one, please expand on what does deployment planning have to do with resilience?
Right. So deployment planning, in essence, is about how you deploy your system to be resilient, right? And the way you deploy your system has a big impact on the system stability, right? So the goal is to prevent system updates from introducing unexpected failures and oh shit moments, right? Excuse me for saying. And there's different deployment strategies that you can use today that are considered industry best practices, but they are not all equal in relation to how um, they impact your system stability. For example, the deploy in place strategy that typically just updates system components without changing the underlying infrastructure is very different from the concept of rolling updates, for example, or from blue-green updates in how they impact your downtime, how they impact your overall system stability, and the perceived stability of your system for your end user, right? So you need to be aware of how your update strategy affect your system's resilience to failure during the update process and post the update and into the regular operation phase.
Got it. So if I've got a 24/7 live customer facing service, um, just taking it down to do an update in place would cause an outage for those clients. On the other hand, if I do a blue green update where I've got an identical parallel but updated system running next to the current system, we can actually test that new system and just switch over the DNS address when we're ready to go with the new system. And that should be transparent to the users, yes?
In theory, yes, of course, the devil is in the details as always. So how you execute on that is, has a big impact on the actual result. And this is where we also talk about organizational resilience, right? In team culture and the practice of DevOps or Ops, and all these have an impact on your system resilience. But for sure, picking the right deployment strategy is key to preventing unnecessary or unwanted downtime beyond what you already planned for.
I got it. It's when you defined resilience, you said, encountering unexpected events or challenges. So what you're getting at is make deployment very expected and intentional. Okay, that makes sense to me. I get it. The next thing on your list
Exactly.
was redundancy. I mean, I think our listeners get that. It's about putting more servers in the cloud so that if one fails, another can take over, right?
Yeah, well, you said putting more servers in the cloud, but does it have to be in the cloud only, or does it matter where the resources are? So redundancy is essentially about putting more servers wherever, right? Wherever your system operates to make sure that you can continue operating when one of those components goes down. And talking about the cloud, it's interesting that we come to assume that the cloud is the be all end all type of an environment for your application today, right?
We
Well,
just spent the
turns
last
out,
10 years moving everyone to the cloud. Yes, the cloud is it.
right, right. Well, it turns out there's the opposite trend nowadays, the concept of reverse cloud migration. And a lot of companies decide to move off of the cloud for various reasons. And two of the strongest of those reasons being first cost, because cloud components cost a lot of money because it's someone else's computers that someone else has to pay for that, right? And it also creates a lot of tension around some key congestion point like big data centers. And for example, when a single Amazon data center goes down, you do get the feeling that half of the internet is down, right? So this pressure creates the interesting trend of companies now considering moving off the cloud and into their own server infrastructure to make sure they can control those aspects of running the software.
So if you have kind of a hybrid model where you've got some assets off the cloud, say to address your, I don't know, maybe your regular or your predictable traffic, but you mean you still have some servers on the cloud to handle unexpected peaks in volume. Um, that's got to make your next point a little more complicated. I mean, you have backups listed next, but I've got assets on the cloud. I've got assets back in my office. Backups now got complicated.
Backups got more complicated than ever, I would say, with cloud components, on-premise components, and the mix of both. So I would say the backup strategy really is very much technology and deployment specific, right? If you are running on SQL-based relational database, for example, you have a certain backup requirement that we probably all know for the remaining, for the last 25, 30 years. But what if you're running on indexed databases, right? Or just some content delivery networks just serving files over the cloud networks, right? So your backup strategies in those cases would be hugely different. And coming up with the right backup plan and executing on this plan so that your backup strategy is not just something that you write on paper and forget about it, but also something that you play over time and you test and drill constantly to make sure it actually works is critical to having a solid backup system that can really react accordingly when something needs to be recovered.
Okay, so that you test and practice regularly. Okay, that makes your next point make a lot more sense, which is recovery and restoration planning. Um, you didn't say recovery and restoration. You said recovery and restoration planning. I'm guessing that has a lot to do with resilience of, doing the right thing with your backups when something bad does happen, right?
Absolutely. Backing systems up is never enough. A lot of people just tick the box of I do backups, but what happens next? Do you know? Have you tried to recover actually a system from a backup? Do you know how much time does it take? Do you know how much time is your exposure, is your downtime exposure to your users if you need to restore from a backup, right? So having a recovery plan, a disaster recovery plan actually is exactly about that. It's a complete plan and execution steps for recovering from the backups that you created previously, right? And if you don't have that, at the very least, you need to be able to answer to two questions specifically. First is how quickly can you restore the system in case of a service disruption, right? So you would note that I'm not just talking about backups now. I'm talking about the knowledge of how you can restore from that backups and how much time is it going to take you, right? And the second question that you need to be able to answer is how much time can your system tolerate to be out of service before you risk losing business, right? So in disaster recovery strategies, this is, there's a formal abbreviation and nomenclature for this type of questions. But in essence, it's about the need to be able to recover the system no later than the time window that you can tolerate for your business. Anything later than that, and you're risking, business and user and user dissatisfaction.
Okay, so one of the points that you listed in your list was failover automation. So let's say that you do have your services are running on two different virtual machines in a data center. One of them goes down hard, and you're going to have to restore from backup. I'm guessing what you're saying is even though you've got that second virtual machine handling all of the load from all of your customers now, you need to be able to get that backup restored or a new virtual machine spun up and then data restored from backups before that your last VM falls over due to load or what have you. So it's looking like a lot of these things in your list are starting to like really kind of connect with each other. Do I have the right concept on failover automation there?
Yes, certainly. So I observed that you're talking about two concepts that are different but very much interrelated. One was the high availability setup, or the ability for a second redundant server to be able to continue servicing requests when your main server goes down, right? This is
Mhm.
HA, this is high availability. But at the same time, you need to recover load balancing as quickly as possible, or the ability for multiple servers to service your requests in balance so that you do not create another congestion point that is now the single point of failure for your system. So these concepts are very much in sync, and they work together in a single strategy that is typically also covered by disaster recovery and DevOps plans.
Seriously,
So
tell me about it. I've played some real time online games, and you can kind of tell when one of the servers goes down because everybody just slows down on everything until they bring another server back up. So yeah, you can feel that as an end user in high performance critical applications. Totally. Um,
certainly,
yeah, that
and
makes
the
sense.
yes, and the automation part, which is the next point that you brought up, the failover automation is now the ability to do that automatically, right? Restarting, replicating nodes. The question of, can your infrastructure detect dead nodes and restart or replicate them, right? And also, very importantly, in addition to restarting and replicating nodes, is your underlying network resilient enough to detect those new respawn nodes and put them into play? Right? Because having them back up is nothing or does nothing if your infrastructure is not flexible and resilient enough to detect that some change has happened in your overall, network of interconnected systems and put everything back together into a working scenario.
Let me
So you
guess, you
need
don't
to
get that
plan.
for free. That's something you have to actually go out and design and code into your system.
Absolutely. You need to plan for that. You need to design it, and you to develop and test it to verify that it actually works, because writing it down on paper is not enough.
Yeah. All right. I keep hoping that now that we're spending so much money in the cloud, that I was really hoping that we would just get a lot of this stuff for free, because we're working with Azure or AWS. But that's not the case, huh?
Well, it does appear to be the case out of the box, right? But it's not always the case, right? Because sometimes the basic tiers of cloud services do not provide this out of the box, or depending on the type of service that you have chosen, it's not an extension or it's not a benefit that you get automatically, and you have to set it up additionally, and sometimes even yourself. So just something running on the cloud does not mean that you get all of those benefits for free. It's still a topic for your development team to plan carefully, to prepare, and sometimes even execute on to be able to really take benefit of those strategies, even in the cloud environment.
Fair enough. Um, the next item here is isolation. I have no idea what you're talking about. Tell me what you mean.
Yeah. So the concept of isolation in software exists on many different levels, right? You can have process isolation, you can have service isolation, server isolation, even network isolation, right? But there's a very popular modern architecture best practice that says that a combination of a good service isolation, or the concept of microservices, along with some server isolation, or the concept of virtual machines or containers now more modernly, gives you a good foundation for resilient software systems, right? It enables the localization or the narrowing of the scope of system failure, so that this foundation creates the ability to have continued service when there's a disruption somewhere in the system, right? The so-called partial service disruption, in which your system continues to operate at some level, and hopefully it's not a critical, service disruption that is preventing most of your users from getting the value of your system, but at the very least, your system still provides some kind of service or promote some kind of value to your users. This is very much in stark contrast to the typical monolithic architectures, for example, where as a monolith lives and dies or fails as a single unit, right? So if you need to build resilience around that, you probably need to invest more in concepts like redundancy, right? That you need to create multiple instances of that monolith so that the combination of those is a resilient system now. Not so much a concern with microservices and containers or other virtualization concepts, because those allow you to isolate system components very granularly so that if one fails, the rest of the system continues to work.
Got it. So if you're worried about your new IoT support taking down everything else in your server, billing and scheduling and everything else, you either really need to work on isolation, breaking those out as microservices, perhaps in containers or on VMs, or having really good failover replication and restart automation for your monolithic service. Um, Seriously, these are all tied together. These all connect to one another at some point. Um, the next one, versioning and rollbacks. Okay, being that these are all connected, I'm going to go on a limb here and guess you're going to say we need to have a plan.
Yes, we need to have a plan, but as I have been saying a few times by now, you also need to make sure that this plan actually works. So how you do that, right? So someday something will happen that requires a rollback, that's for sure. Actually, rollbacks are far more common than most people typically anticipate. It can happen out of something even in your control, right? For example, a rookie developer in your team breaking your login page, right? And all of a sudden, none of your users are able to log in, right? Or it can be something out of your control. For example, a third-party component that you just updated does not work properly in the most popular browser that your users use, right? All of those cases require you to immediately roll back. Now, you do have a rollback plan, right? That's great. Now, do you know if it actually works? Have you tested it? Do you know that the moment you need it in this critical, high tension situation, that it's actually going to be of use to you? So you need to be prepared. You need to have a plan, but also you need to test and make sure that this plan actually works.
Good point. I remember we had to do a rollback of one specific feature because of privacy legislation in the EU, and we get it was passed, it went, and then we needed to roll back that feature. So yeah, definitely having that planned was helpful. Testing.
Yeah, so testing, it's all about testing, right? Because having plans is nothing if you are not sure whether these plans will work. So, you know, people do fire drills, right? Even in the military, having a plan is nothing if you're not prepared to execute on this plan. So testing is a big part of the entire resilience strategy that you adopt. And by testing, I'm not talking about just unit testing or integration testing. You need to have an overall system testing, you know, data and metrics that that prove to you that your system is resilient to failure, right? So in addition to planning and having plans, you need to practice your plans. Testing allows you to perform drills, to perform tests that actually go and break things, and then you observe and improve your system recovering from these failures. And there is a very good case with Amazon, for example, that people have been reading all over the place in the hot days of the cloud. Amazon deliberately introduced random failures in their production systems in Amazon Web Services. So they have automated test agents that randomly shut down disks, purge RAM, disconnect the network, and kill processes in production systems, mind you. So they continuously test and improve and also automate the recovery procedures in their production environment. And they are champions at disaster recovery automation because they can allow themselves to test in real time and to make sure that their drills actually work by just their failure, their inclination to failure allows them to really introduce much more failure than force majeure cases that typically others encounter by just being very proactive and very prepared for it.
I'm as a large Amazon user, I'm glad they do that, but I really hope they don't do that on Black Friday or Cyber Monday. Really, could they like not bring their own systems down then? That would bring me comfort. Yeah,
Yeah, they
but
probably tell their testers to hold their horses during Black Friday. I would
so
imagine that.
we've it seems that resilience is as much based on the team and training and practicing plans as it is about writing code or just setting up more VMs. So the resilience really does kind of need to be organization wide as well as, throughout your code. Um, that's something I don't think gets a lot of press. I don't think a lot of people talk about that.
No, not enough is being talked about organizations being resilient or being flexible enough to create resilient systems, right? Because you typically have people with very specialized, roles and tasks in an organization. And resilience is really about being much more agile than is typically required for building software, right? And we all talk about agility and, agile methodologies in being software. I would say building resilience in software is agility taken to the extreme because you're not only preparing for the system requirements that you are tasked with building, but you're also preparing for random failure and then how this failure will affect your system, and it will affect it by all means you can imagine, and then being able to recover from this failure. So to be able to efficiently prepare for this type of resilience, organizations need to be not only agile, they also need to be very much prepared in terms of strategy and thinking and practicing chaos, practicing failure and practicing resilience on a daily basis. So this is to me the essence of resilient organizations that produce resilient software.
Absolutely get. I mean, I don't know any systems that are getting less complicated and have fewer dependencies. It's only getting more complex to the point that you speak of. So we've gone over. Let me look at our list here. We've gone over deployment planning, redundancy, backups. We've gone over recovery and restoration planning. We've talked a little bit about load balancing and failover automation. Good discussion about isolation. Um, Monitoring and alerting, you kind of touched on that a little bit when we were talking about testing and failover automation. Versioning and rollbacks. Boy, big takeaway there. It's not if it happens, it's when it happens. I totally agree with that. Um, and then testing. Dear audience, if we have missed something or not covered something in detail that you would like us to cover, we're going to go ahead and write this out as a blog post and include the transcript of this and some of the other things in more detail that maybe we didn't cover here. So hopefully there will be a link right below me and Belly on the screen that you'll be able to click on to take you to that blog post, and you can get more detail there. Belly, as always, I really do enjoy your conversations. Thank you very much for joining us, and join us next time on Modernization Accepted.